Day 6th of, I don't know what day it is today. And also welcome to those joining us online. I am Professor Tolullah. I am a Professor of Global Public Health and Sustainable Urban Development at the University of Cambridge. And I'm pleased to moderate this session. I'm also a Fellow of the International Science Council, so it's a real pleasure, and of course I couldn't say no to this to this request. So we've got a great panel lined up for us today. The focus is looking at, it's been organized by the UK Royal Society and the International Science Council, of course, and the purpose is to look at how to accelerate science-based action, and particularly focused on understanding better aligning the economic impacts of climate change with the science. Now, we know that the science has played a really critical role in advancing the discourse and driving action for tackling climate change in the last few decades, on one hand, and there's also been a lot of work done looking at the economic impacts of this. So, you know, the two arguments, I come from the health side of things, and the health argument and the economic arguments, right, tend to be the most powerful drivers for action. So we know in the economic space there's been a lot of work on that, but to some extent there's been a bit of a missed opportunity to align some of the work happening in these different disciplines. And so we really need to have fundamental changes in how we do science and how we optimize the opportunities to really show what the economic impacts are of climate action. This will be, I think, particularly important as we engage with some of the synergies. So I seem to have spent a lot of today talking about synergies between either health and co-benefits of climate action, synergies between the climate action and the Sustainable Development Goals. And these synergies really are going to be important. We're going to have to think differently about a new kind of science. So what we will be doing in this side event is presenting some of the key findings of the work that's been undertaken by the Royal Society and the ISC on how to better understand the economic impacts of climate, and really how we can start to accelerate science-based climate action globally, locally to globally. So I'm going to introduce our esteemed panelists, and then all in one go, and I'll invite them in that order to give us share their thoughts in 10 minutes, and then hope we'll have time for some discussion and really welcome your engagement as well. So first, I will introduce Professor Jim Skea, who is the IPCC chair, who will be exploring the economic costs and the views from the IPCC. And then we have Professor Detlef Stammer, who's from the Center for Systems Research and Sustainability at the University of Hamburg. Professor Stammer is also an ISC fellow, and will be exploring the current and future priorities of climate change science. Next to him, we have Professor Cameron Hepburn, who is the Babcock Professor of Environmental Economics at the Smith School of Enterprise and the Environment at the University of Oxford, the other place, who will be looking at the physical climate science and looking at how economic assessments fit within that and how to improve our estimates. Penultimately, we have Professor Zakri Abdul Hamid to my left, who's chair of Archery Advisory and ambassador and science advisor for the Campaign for Nature, and also an ISC fellow. So Professor Hamid will be talking about how we think about accelerating climate action globally, and presenting a kind of roadmap for discussion. We have one more panelist who will be joining us a little bit, a few minutes late. I'll just introduce her in the interim. It's Persson, who is Research Director and Deputy Director of at the Stockholm Environment Institute. And she will be looking at how this science can accelerate progress on SDGs. So really you can start to see how the complexity we are confronted with needs us to work better together. And so without further ado, I will invite Professor Skea to share some thoughts. Thank you.
Okay, now it's well known that the IPCC chair is an expert in absolutely everything, and that I've so far done critical minerals, water, ancestral knowledge, and now impacts and economics. So bear with me if I don't go too much in depth into this. So just to say, this could be quite a short talk, because in fact I think in Working Group 2 of IPCC, economic perspectives have not been very much to the fore so far, and I think we have to admit that. So if we look at how Working Group 2 has tended to frame the question of impacts and adaptation, it has taken very much a risk-based framework. And this propeller diagram has actually informed the last 2 cycles of IPCC Working Group 2 on impacts, adaptation and vulnerability, pointing out that risk is a function of hazards, exposure to these hazards and vulnerability. And economics has played a less dominant part in the overall thinking and framing of Working Group 2. An important element of it has been the degree of the handshake between Working Group 1 and the physical science and Working Group 2 on impacts. And the sort of the conceptual handshake has been through global warming levels, say 2 degrees, 3 degrees or whatever. And it's worthwhile saying that that is a very static approach to it, because it doesn't take into account the history by which you might have got to 2 or 3 degrees warming, which I think is an important point to make. So at the top of the diagram, you've got the kind of the picture. This is what you can take from Working Group 1 and says how warming might take place in different parts of the globe. Very obviously, greater warming at the higher latitudes in the northern hemisphere. And then Working Group 2 colleagues would assess the literature to try to look at the different impact categories. And I've just taken one example from the Working Group 2 Global to Regional Atlas, as they've described it, which for 2 degrees warming, what is the degree of habitat loss that you would see in different parts of the globe? And this is kind of the way that the systematic way that Working Group 2 has worked through it. They have also relied very heavily on the so-called burning embers diagrams, which I think started out as a communication device where the intensity of the colour represents the level of risk. And just to flag, there is a story behind that. For example, the purple represents risks that are severe and irreversible. So there is some kind of definition behind the colour. And just to say, certain colleagues have actually pushed us ever further on that. So there is even significance to the Pantone number and where that actually changes in terms of the level of risk. But this is the way the thinking has developed. Now, I did a quick scan through the Working Group 2 report from the last cycle to look for economic concepts. And there were 2 topics that were really covered. One was the impacts of climate change on food prices. That actually got quite a lot of attention. And the second part was to assess the overall global aggregate economic costs of different warming levels. And one of the things that happened, there was much more collaboration between Working Group 2 and Working Group 3 in the last cycle. So we produced a cross-working group box, which appeared in both reports, which tried to systematically compare the value of the avoided impacts at different levels with mitigation costs. So that was coming in there. And frankly, Working Group 2 did the pictures better, and Working Group 3 got the words better, in my view, if I can do a very quick summary. So this is from the Working Group 2 version of the box, and it's looking at impact costs from different studies at different levels of warming. And to put it bluntly, you can see that it really is all over the place in terms of the levels. And what the different colours actually represent is the different methodologies that people used to arrive at these global aggregate impact costs. So just say that the standard kind of integrated assessment model, the DICE model, developed by Bill Nordhaus, is kind of the curve that's rising and moving steadily upwards at the bottom of the diagram. Various characterized as structural modeling in the picture in the top right-hand corner. And the green ones, which are much more extreme in terms of costs, are based on regression modeling, where you actually looked at inter-annual variability of GDP and compared it with temperature changes. Just to say, I am epistemologically challenged by that particular approach and the large numbers that come out of it. But this was assessed in the Working Group 2 and the Working Group 3 reports. So quite a wide range. Now, in terms of I'll skip the Working Group 3 because they didn't do the pictures as well. But the qualifications that came out of Working Group 3, I think, are worthwhile noticing and were referred to at the Royal Society meeting that's been referred to. So on the mitigation side, missing elements of dynamic realism, inertia, induced innovation, path dependency, and on the impact side, missing non-monetary damage, the uncertain heterogeneous nature of damages, and the risk of catastrophic levels of damages. And there is emerging literature that has started to address these gaps and start to integrate it into cost-benefit frameworks. And that includes, for example, damages on capital and growth, which I think is a very important element to bring in. Now, the last bullet at the bottom of it, even if you ignore all these things up the top and just do the narrowest of narrow cost-benefit analyses, it was concluded in the report that without taking account of anything else, that the benefits of limiting warming to 2 degrees outweigh the global mitigation costs. However, in spite of pressure from many governments to say the same thing about 1.5 degrees, it didn't quite stack up when you were actually looking at the literature, which is why this very carefully worded phrasing actually came out in the end. Now, I was going to say thank you at this point, but let me just make 2 or 3 pleas to finish off with. A lot of the literature at the Royal Society refers to integrated assessment models, and there are 2 kinds of integrated assessment models. There are the cost-benefit models of the Nordhaus DICE model variety, but these are getting less and less attention in IPCC reports. When we talk about integrated assessment models, we are much more talking about the cost-effectiveness models that are used in Working Group 3. Because the Nordhaus approach might help you to decide how ambitious you should be, but actually we've politically decided how ambitious to be. We've set 1.5, so the new question is, what is the best way to do it? It's really important in the future that we get good handshakes with Working Group 1, which I'm sure Detlef will be able to tell us about, which in the next cycle could contain more granularity geographically about effects and perhaps more attention to extremes as well as averages, which is important. We are also going to be challenged by governments to provide help for the global goal on adaptation. And there the question of indicators, which may not be economic, but could it include it, will be, I think, an incredibly important element. And just a very final thing to say, I think Working Group 2 needs more economists and more people who are attuned to particularly the financial challenges of impacts and adaptation, because I don't think there was enough of that in Working Group 2 in the last 2 cycles. But I'll conclude there. I'm not sure whether I was within time, but it must have been about
perfect.
right.
That was perfect. Thank you very much. That was really helpful just to set the scene on where we are. I definitely have a couple of follow-up questions, and I hope you do as well in the audience. But we'll move on to the next speaker. Professor Stammer, just in light of what has just been presented, what do you see as the priorities both now and in the future for the kinds of climate change science that we do?
Yeah, thank you very much. First of all, I am a physical climate scientist, so I'm not an economist. I have no idea about this, but I will make a few blunt statements just to stimulate the discussion. The other part is I'm actually here as a chair of the World Climate Research Program and not as a professor in Hamburg. And the World Climate Research Program, as you can see in the bottom, is actually one of our parents, one of our co-sponsors is the ISC, and that's where this link comes from. And I'm here in particular, I mean, the title was given to me, Current and Future Priorities for Climate Change Science, but of course WCRP is covering mostly the natural climate sciences, also collaborating with futurists on the more the human part, but we did have a large conference not too long ago. Jim was actually online. I saw on their flat screen. It was still great. This was in Kigali in October 23 to 27, and it was an extremely transformative conference. We really brought together many communities, different expertise, politicians, decision makers, but also we did it actually deliberately in Africa to be in the global south. And we had more than 30% of the participants, you see it in the bottom line, total 1,500 delegates, 32 from Africa and 26 from the other parts of the global south. So I think it was an extremely good representation from the global south, and this whole discussion was first of all driven by the problems of the global south. Africa, for instance, in recognition of the disparities of the drivers and consequences of climate change around the world, inequities in the global science community that undermines the disadvantage of the knowledge contribution from communities in resource poor nations, and really we wanted to address both. And this community that came together, and the pictures, in fact, one of from the conference, really, first of all, acknowledge the problems. The world is in a state of polycrisis leading to cascading systematic or systemic risks and increasing inequality. That's what you just said. This will increase. Basically, we have already, with the temperature change, an increased probability for complex and compound extremes leading. We see it in the literature or in the news all the time. Hazards, flooding, weather events, storms, fires, it doesn't matter where you go. And human-induced changes have led to profound, widespread changes. The temperature, the whole debate here, the IPCC said it already at the launch of the last assessment report. We are very close to 1.5 degrees. All the discussion here is kind of mute to some extent. Any further delays will make this situation even worse, required really unprecedented societal and technological transformation. And I will come back to this. This really needs to go across the entire society in all sectors working together. But the thing, and this comes to my title, the climate, the community there really defined where the field needs to go, and it made, it's called the Kigali Declaration that will come out very soon. One part, and I'm reading this here just, is actually addressing the climate science community. And first of all, the delegates call on the climate science community to give equal visibility, voice, and opportunity to early career scientists, marginalized scientists, and give them resources. Expand the scope of climate research and collaborations to bring integrated knowledge to the understanding of human systems, ecosystems, biodiversity. Advance transdisciplinary engagement with policymakers in the co-design and co-creation of actionable knowledge. Prioritize pathways for translating observations and model data into actionable climate information for informed decision-making and resilience building, advocating the practices of open science for all, really. I mean, this was a big topic, and data for all, education, and support the effective adaptation in the global south. And the last point, it's a kind of a little anecdote or just a comment. Sometimes I hear in this week, for instance, I have the feeling maybe it's not exactly clear what IPCC is doing, what WCRP is doing, and Jim really used already the word assessment. IPCC is there for an assessment. WCRP is there to define the science, to do the science, to actually develop the knowledge and deliver the knowledge in the literature that actually Jim comes and assesses that knowledge. So I think that's one point that might even here with UNFCCC and others might be more important. The other part that was called for is actually, and that's again from all the delegates, on the agencies, governments, private sectors to work with the climate scientists, really to work together and mobilize resources really to create actionable information, implement climate adaptation options, provide improved climate change projections with context-relevant information. That's what Jim then actually assesses for the pictures he showed. And hence long-term sustained and accessible observations and paleoconstruction, including indigenous knowledge, and establish improved climate information and early warning services down to the local cities, regional scale, for information, adaptation, disaster risk and reduction strategies. The last point again is a little bit provocative, but my impression from various meetings and as a natural scientist is that maybe not so much the economy, but definitely the financial sector seem to be very much separated from what's going on in the climate system, the climate problem. And so I think this is where also the top line comes in. We really need to work together. Now the remaining slides, I'm not sure how many minutes I have. I can stop here. The remaining 3 slides are just kind of what we identified of what needs to be done. And maybe I just quickly go through this. There's fundamental research, Earth system interactions. We really need to better understand the top figures. For instance, this year's spike in the global warming, we don't understand where this comes from. We don't understand the non-linearities in the problems of feedback. We need to improve the forecast, the models, reduce the biases, and improve the observational capabilities. And you see the lower panel, the observed precipitation or rainfall, and then the one black line is what we can simulate with climate models. That's a seasonal cycle. You basically see it immediately. There's a lot to be done. Attribution, predictability, and predictions where we need to come better. Human interaction with climate. This is, I think, also very much at the heart of Working Group 1. We better need to understand also stocktake, the global cycle of energy, carbon, and water. I mean, it's really, it sounds, we worked on this for a long time. We still really need to improve this, in particular the water cycle. For this purpose, we actually launched what's called GPEX, a global precipitation experiment to better understand and predict the rain. Human interaction with climate, impact of climate change on sea level ecosystems, food security, water availability, human health, cities. These are all immediately important for society, and we need to work together. You see basically the science we define goes far beyond the natural science. Interaction with climate change, natural people, nature and people, mitigation scenarios. And this comes back to the IPCC scenario description, where we also need to bring in actually the understanding of climate intervention. Not that we want to advocate it, but we need to understand particularly the risk. Right. The last point is very quickly, the co-production of climate services and solutions. That has local perspectives, it has open science. Was a really big topic, the open science, availability of everything for everybody, really climate information for everybody, and the co-production. These are all really the headlines of what we identified where we need to work together, and we have to do this across all climate science programs, and that certainly includes Future Earth. Thank you very much. Maybe I stop here.
Thank you. So that's really helpful to set out the priorities, not just for the science, but also how to get the science actioned, right? And we'll come back to that. So, but moving from the physical science perspective, let's move to the more economic context. So, Professor Hepburn, having just heard what was just presented, what do you see, what's in your experience been around how this physical science is considered or operates in your context?
Thanks, Tolullah. And I appreciated your concern about having someone from the other place up on the panel, but trust me that I'm very Cambridge friendly. My in-laws are from Cambridge. I just had a meeting with a friend from Cambridge, and in fact, Cambridge is Oxford's most famous and most successful spin-out. So just to remind you
I knew you'd cause trouble.
of that fact. So no, what I my reflections on both Jim and Detlef's talks, Jim, to begin with, of course, he's the most humble and self-deprecating man. When he says he's not an expert on anything and then he somehow manages to be an expert on everything, I think you do have to listen. And there is increasingly good coordination between, I mean, we're making progress, I think, in terms of connecting up the physical scientific models with the social scientific models. And Detlef identified a few of the really key feedbacks there, and some of the dynamics and nonlinearities that I'm going to focus on. And you're both admirably brief, so I'm going to try and continue with that trend, but I may fail. So what I wanted to say is three main things. I mean, we are getting better, but there's a sense in which, for at least the last couple of decades, there's been a whole train of climate economic modeling that has been letting us down, and even, I would say, harming the reputation of economists with physical scientists. But we are starting to do better. And the three things I picked out, there's a long list of things I could have picked out, but the three, I think we're starting to resist these aggregate communications of just GDP numbers. Okay, Jim, you put them up, and that's understandable, but you also put up multiple estimates and ranges. And I think it's also very important to go granular, get a higher level of resolution, and tell stories that help people to actually understand, because this is an assessment and a communication process. And I think economists are starting to get better at that. The second thing I'm going to address is the point Detlef raised about nonlinearities and tipping points. And these are actually central to the whole dynamic shift here. It's a transition that is not going to be smooth. It's not going to be linear. It may not even be continuous. It may be discontinuous. We know in nature you can have not just non-linear changes, but structural changes where you've got a bifurcation, you cross a threshold, you get a collapse of an ecosystem. The mathematics of that is well understood within ecological sciences, but it's actually non-trivial to bring that into an economic model. And because it's really hard, we say, yeah, no, it's going to crack, it's going to break my model, I'm not going to do it. Well, I think we're at the point where that's not good enough, because it might break humanity first. So we actually need to model it and get a sense of where these socio-economic tipping points are, because some of them are good, right? I mean, I think, if we do peak emissions in 2025 or thereabout, we're then swimming with the tide, and a whole lot of things that feel hard start to feel easier because you get coordinated expectations around particular states of the world, and investment flows change, capital flows change, and actually, I mean, economics it's a social science because our own beliefs about the future aren't mere beliefs. They affect the future because we behave on the basis of those beliefs, and then our behaviors make the future. So you don't have to be Donald Trump to have a belief and then see it turn, as ridiculous as it may be, I can be president, and then see it turn into reality because you've believed it strongly enough and others believe it. I mean, that's probably not a good example anyway. I should stop ad-libbing. And it's 6:30. After 6:30, we probably all need a drink. Okay, the third thing I want to say is that I think we're getting to the point where we accept that there are very important things that can't be modeled. That's not to say you give up on them, you leave them out of your model, but it does mean you have to be very clear in qualitatively communicating those dimensions and having a go at saying, look, this can't be quantitatively modeled very well, but we're going to try to give you a sense of just how important this is. Because if you say, well, the numbers suggest GDP losses of 5 or 10%, and there's a bunch of things that aren't in the model, a policymaker's got every right to say, well, how important are those things that are not in the model? Like, is that 5 to 10 becomes 6 to 11, or is it 5 to 10 becomes 50 to 100? Because if it's the latter, I'd like to know about them. So I think if there's a theme of this talk, it's a theme around humility, really. So I'm probably out of time already, and I haven't started yet, but let me whiz through this. It is late, so I thought I'd give you some humor. Sometimes things don't just add up. Somebody should probably tell the guys in that town, but I suspect it was probably a joke, so maybe the joke's on me. And because we're missing things out, when you start to deliver messages within aggregate GDP, like optimal warming is 3.5 degrees, you get these kind of, and I don't support this sort of headline, but I think it is indicative of the challenge that economists' reputations are coming under. I mean, I was an engineer before turning into an economist, but I feel this. I don't want to be considered to be in an elite clique of math-addled economists hijacking climate policy and causing mass destruction and loss of life. So, but I mean, we do need to perhaps laugh at ourselves, I think, if the model's saying 3.5 degrees is optimal warming, and ask ourselves what's wrong with the model. Jim's point is taken very, very strongly, that actually, thank God, we're not in a cost-benefit analysis framework. We are operating in a cost-effectiveness framework. The political process has said 1.5 to 2 degrees, so we're not having conversations about 3.5 degrees. But this chart from colleagues all around the world, some from the LSE, some from other wonderful European institutions, shows that even with basic models, you can get an outcome that says 1.5 degrees to 2 degrees is optimal if you change the assumptions in a way that makes them a bit more realistic. So you change the carbon cycle assumptions, you change the climate system assumptions, the damage function, the assumptions around, or at least assumptions is less correct word as the position that you take around intergenerational welfare, and so on. And so this is slightly undermining my point that we need more granular models, because even in a grossly simplified aggregate model, you can get plausible outcomes with more useful assumptions. But the bottom line I want you to take away is we want to stay granular. Now, I just want to, in a slightly edgy way, share with you some work in progress now on how we may actually go about confronting some of these tipping points. This is some work at Oxford at the Institute for New Economic Thinking. We see, when you look across several dozen different product categories, that there are some that do not seem to show any learning. They don't fall in cost, let's call them commodities, and others that do fall quite strongly over time. And these technologies have rates of progress that turn out to be quite predictable. If you look at oil, coal and gas, they don't show that kind of progress. Their prices move around a lot. You have fracking that drops the price of gas, but actually on a multi-decadal scale, they are basically flat. And they're volatile, but there's no long-term trend. They're roughly as they were in 1880. Now, if you compare that to the renewable technologies that we have, and you plot them on a log chart, so these look linear, but they're not. These are exponential declines in cost. And we can say predictable things about these cost declines across batteries, power to X, wind, solar, because the error bars, once you've established a rate of learning, seem to be relatively low. These are the sorts of things that economists are starting to build into the model so that we can get more accurate assessments of how we balance those costs and benefits, as Jim was pointing out earlier. And we had a paper out just on Monday showing that CCS doesn't seem to have very rapid, if any, learning. That may or may not turn out to be true as we look at different types of technologies, or may or may not be true in relation to carbon removal, but insofar as we've got an evidence base, it says that fossil plus carbon capture is not learning. All of these renewables do show learning, and that is quite significant because it takes me to the nonlinear piece, which is that when you have technologies that learn, you have these kind of exponential penetration curves that take a rough S sort of shape, whether it's ships to steamships, horses and carts to cars, or typewriters to computers. And if you have a think about where we are in the energy transition, humanity always wants to draw straight lines. That's what we do. And even if you kind of mathematically can get your head around the fact that as we did with cell phones, suddenly they're in everybody's pocket and it only takes you 10 years, it's very hard to get your head around the fact that suddenly there'll be no fossil fuels. Every car will be an EV. All your power will be solar, wind, and batteries, or other bits and pieces. And of course, it's not entirely true. But the point I'm making is that most of us instinctively mischaracterize, underestimate the speed of transition here, And that plays out also in some of the models, although, again, we're getting better at that now. We've been doing some work, this is Leonard Baumgartner's work, which is really excellent, on taking dozens of different technologies that have followed S-curves and trying to get a way of forecasting how things may move in the future. So we can do more than just say, oh, shucks, it's going to be nonlinear, it's going to be disruptive. We might be able to say how fast these transitions can happen. Okay, and then the last point you'll be pleased to hear is the point on admitting defeat, that not everything that matters can be properly quantified. And here, it's, I think, an unstated assumption of almost all economic models that they're based around what matters is a set of consequences rather than the way those consequences are achieved. So it's a moral philosophy, a branch of moral philosophy called consequentialism. There are other moral philosophies, but we don't tend to use them in our economic models. And then within consequences, we focus on human welfare. We ignore the welfare of other species when we're thinking about our economic modeling of climate. And then within human welfare, we think about this construct of utility, which then tends to be translated to human consumption. This is a very, very narrow moral philosophical way of thinking about a problem that affects everyone all around the world. And so I think one of the things we need to do is to start to make the invisible visible and say, well, we do use this framework of analysis. It's not even a mainstream moral philosophical theme. We use it because it enables us to do quantitative work more easily. But there are many other things. There are ideas of rights. There are ideas of culture that aren't captured when we think about the losses that show up in an assessment of GDP in 2050 versus some baseline scenario, whether it's the Parthenon or your favorite species of sea turtle. So there's a lot missing, and we need to admit that that's missing. And rather than pretend that we can price it, just make it clear in words what we lose if we don't act now. Thanks very much.
Thank you. Thank you. There's so much to unpack from that, but I'm just going to move us on because to Prof. Hamid, bringing together the physical and the economic side of things, we know that we're dealing with complexity here, and one of the barriers to action is often a lack of accountability in knowing what roles people have to play in actually acting on the evidence. So we'd love to hear your thoughts on what you think, on how science can accelerate, or how the action can be science-based, and how that action side of things can be accelerated.
Thank you, Chair. I'm honored and delighted to be here. I also wish that this audience need only be attended by academics, scientists, but also delegates outside there. They should be part of this conversation. And I'm saying that as someone who had migrated from an academic position at the university in Malaysia to a science advisor, to the negotiation, and eventually one of the negotiators. And I started this more than 30 years ago when the UNFCCC was negotiated at the Earth Summit. And I was negotiating in the UN Convention on Biological Diversity. So for a long time, we scientists have been talking to ourselves. And that's the disconnect. What we should be doing is linking to the world outside there, in particular, our political leaders, in particular, the policymakers, the public, and the rest. That has not been going on. I also speak on behalf of my experience as the founding chair of the Intergovernmental Platform on Biodiversity and Ecosystem Services. So this disconnect. And ladies and gentlemen, I'm here to present to you a report produced by the committee on how to take this matter forward. And this is commissioned by the International Science Council, as you know, the biggest science council in the world today, which originally originated as the IPCC, International Council of Scientific Union. And this is a report, the General Commission on Science Mission for Sustainability, chaired by a politician, Helen Clark, the former Prime Minister of New Zealand, and Madam Irina Bokova, the former Director General of UNESCO. And you can see here, they are not only scientists, Nobel laureates, but also political leaders and senior policy makers. And this is the report, Flipping the Science Model. I hope you all could download this volume. So, ladies and gentlemen, the limits of the current science system that slow progress towards the sustainability goals. And this is one of the problems also faced during each COP. And here we are at COP 28. That's a lot of meetings. And these are some of the problems. Knowledge on sustainability challenges, but mostly we are having it on the disciplinary and siloed nature of scientific efforts, not designed to deal with complexity, persistent disconnect between knowledge and action, focus on problem understanding rather than on helping to solve it, top-down planning, production of information that is not trusted, intense competition, and organizational and funding mechanism not fit for purpose. These are the set of problems that doesn't filter to the negotiating hall, as we are finding even here at COP 28. So the Commission has proposed this following model. It should focus on how, not on what, okay? And we need science that engages with society to generate actionable knowledge in the pursuit of sustainability. Too often in the past, academics or scientists are too happy to be among themselves in the ivory tower or among groups like this. We haven't really reached out to the policymakers. So goals of the proposed model are outlined here. We need to harness context-specific, actionable knowledge to address the most pressing demand-driven sustainability challenges, or what we call nexus challenges. We need to build trust and legitimacy through broad stakeholder, which is then co-designed, co-produced, and co-implemented, and promoting complementarity, integration, and coordination. These are quite loaded terms, but it is necessary if we need to move on. And here is a proposed structure that is trying to establish a regional science mission for sustainability, which would serve as the boundary-spanning platform for mobilization, coordination, and alignment of diverse relevant actors. And this diagram shows the modality. The main mission here again is to co-design, to co-produce, and co-implement. And that is the heart of the science mission operation. And it shouldn't even be advice. It should be options, which are should be credible, we should be policy relevant and not policy prescriptive. Next, these are the required capacities, capabilities, and expertise. I listed quite a number of those elements, which is quite understood by us, but sometimes we don't walk the talk. So what the International Science Council is trying to propose would eventually be a global network of regional science mission for sustainability. There should be implementation phases, and we are trying on a global scale 20 of those centers linked through a global knowledge sharing platform. And some of the elements here is the need for a fundamental mind shift in funding culture, a big science approach applied to sustainability challenges. And we are also talking about a rough funding estimate of these 20 science missions and knowledge sharing platform at 1 billion per year, which is not even 1% of the global R&D investment, with a significant potential return on investment for global society. So there should be a call early next year, and eventually these are the outcomes. This is my last slide. We should be aspiring to create a novel mechanism to fast-track achievement of the SDGs in regions where progress is lagging most. And you know where that is, you know. And then the building of a global community of a mixture of science, policy, and stakeholder expertise capable of resolving complex and nexus SDG matters. One element which is very important, and again, as a former negotiator, I found this trust is lacking between the scientific community and the societies it serves, in particular the diplomats, whatever, and eventually promoting cultural change within science and science funding. To conclude, I think this science policy nexus is so necessary if you want the scientific message to be understood and accepted and considered by our negotiators, our political leaders, and eventually our policymakers. Thank you.
Thank you. Just riffing off a point you made early on, can I just check in the audience how many people will identify as coming from a kind of knowledge production background, so researchers, science?
Including us.
Okay. Can I get a sense of the people who didn't raise their hands, what your backgrounds, where you're coming from? Capacity building. Policy advice. Civil society. Okay.
This lady here.
Banking. Okay, that's really fantastic. So maybe all is not lost yet. We're not entirely all speaking to ourselves.
I think there's always hope,
Yes.
as long as we keep on talking.
Absolutely. Right. So it's really great that we at least have a spread here. So it's really great to have you all here. And I'm sure online we have an even wider diversity. I really liked this transdisciplinary approach that you proposed, recognizing the importance of new methods and new methodologies, in fact, of generating evidence and moving that to action. I think that's particularly important when we're looking at the complex issues where you have synergies. So moving on to the final speaker, and just by way of tangent, there was a recent report from UNDESA and UNFCCC looking at the climate SDG synergies, and I'd really encourage you to have a look at that if you haven't already. And one of the stark findings was that there was huge amounts of synergy between the climate action and 80% of SDG targets. And yet, as I mentioned earlier today, when I asked somebody who was presenting at the SDG pavilion yesterday, and I asked for directions, I couldn't find it. I said, where's the SDG pavilion? One of the organizers in the building asked me, what does SDG stand for? Right? So we're still at that point where we need to optimize the synergies between that. So moving on to Osa, can you, from your perspective, kind of reflecting on this kind of science to action and thinking about SDGs and climate action, how do you see science and the role of science as a vehicle to harness and accelerate this kind of synergistic action?
Thank you very much. Apologies for arriving a little bit late, but I think I've captured most of what was said in the previous presentations, and indeed hope to reconnect with some of those themes. And thank you to the International Science Council for inviting me to speak on this topic. It's the last presentation. I will try and keep it short and sweet. So I wanted to use this opportunity to reflect a bit on recommendations, insights, learnings from 3 initiatives I was privileged to be part of this year. And when putting these together, it struck me that they sort of address what we could call 3 different tempos when we talk about harnessing science or sort of working within this science policy practice interface. I'll talk a little bit about upgrading the system, reconnecting to what we heard from Professor Hamid. How can we sort of upgrade this system to work even better? And also share some learnings from the Global Sustainable Development Report. So now we are more in the SDG territory. We heard previously more about the climate change specifically, where I will try and distill a bit what we recommend there when it comes to promoting science-based tools for supporting governments in their kind of medium-term planning. And then finally, reflecting a bit on the 10 new insights in climate science, which was just launched earlier this week, of course was supported by the World Climate Research Program, and maybe other people in this room also contribute to that process. So when thinking about the system, I actually chose the term here, upgrading rather than transforming. And this is not to, reflect a lower ambition necessarily, but what I have observed in recently is that science is being contested in many places now. And I think it's quite important to not give the impression that it's totally malfunctional. Actually, we do have a lot of science interfaces that are very functional that we should keep legitimizing. So we need to upgrade and improve, but we are not starting from scratch. And I think that's a potentially dangerous kind of image to convey. But some of the recommendations that came out from this report, which was an outcome of the first ever Science Day that we conducted just before the high-level political forum on the SDGs, gathering around 150 scientists and policymakers. These were some of the recommendations that came out. We already heard about the need to draw more on local knowledge, and I would say this is more than a cliche. We often hear this, but if you look at the SDG targets, for example, much of the competence and mandate and budget to actually take action on them, you find at local government level. So sometimes in the scientific community, maybe we have a tendency to focus more on the global level, but actually the local actors are a very important target audience if you want to improve policy in practice. Of course, addressing global north and south imbalances. This is also something we heard about previously, and it struck us when compiling the Global Sustainable Development Report that especially in the scenario literature, for example, we have quite big geographical gaps. Open access to science, and independent evaluation, accountability, and I think this is also very important when we now have these global regimes, the SDGs and the Paris Agreement, which are not particularly legally binding, let's say. We are really need to step in as science to help provide that independent evaluation of progress and delivery on commitments, and forming part of that broader accountability regime. And finally, an important recommendation was exactly this mission-oriented approach to science that was just described to us. So moving on to this second tempo, which is, is maybe more goal-oriented, or we have a clear, mission, how science should contribute. I think what we realized when working on the SDGs, and it's a very big question, how do we achieve the SDGs by 2030? It's quite clear that it's very difficult to make progress in the short term. The SDGs address really fundamental societal processes and challenges, something it's very difficult to transform overnight, of course. At the same time, if we get too focused on the very long term, maybe we lose some policy relevance. What could happen in the existing or in the next electoral cycle? So I think medium term is a kind of important time scale to keep in mind. And what we try to do in this report, which actually I would say picks up a lot on the science we heard about on the transformation process, the S-curve, how this uptake of new technologies and also social innovations, how does it happen? We came out with these 3 recommendations. So one is for science to help different contexts, whether it's countries or local governments, to identify these tailored approaches to removing key roadblocks and resolve goal conflicts. So I think there's especially a role here for social science to help anticipate more these sort of sources of resistance to change that we can expect. So that was actually also part of our message, that yes, we need to, of course, focus on synergies, but at this halfway point of Agenda 2030, let's get real also on the goal conflicts that we need to address. So we provide some recommendations here on how to undertake that transformation pathway planning, focusing a lot on that process element, and to add something to what we heard from Cameron Hepburn there on the S-curve. We also discussed that inverted S-curve. What are the unsustainable systems and solutions that we actually need to phase out? And another theme that came through, and what we heard a lot from policymakers in their demand for knowledge and science-based knowledge, is the need for exactly finding the cost-effective policy instruments or solutions. And this is also something I hear now as chair of the Swedish Climate Policy Council, and I've been meeting with other climate change committees here at the COP. There is a strong demand now from policymakers on exactly learning about cost-effective approaches. So how can science lean in and try to support in that type of analysis, also using existing tools to try and quantify SDG interactions, where are the most promising synergies and where are the trade-offs that need to be tackled. And we also discuss how can science and government sort of collectively build capacities for transformations. These are sort of capacities such as improved foresight, improved methods for stakeholder engagement, conflict resolution. And finally, my last slide, I think it's interesting also to reflect a little bit on this report, and I'm sure others here also have reflections to share, but I think with the urgency that we have today, and also how quickly our global environment is changing, there seems to be a strong case for having sort of more frequent science advice. That is still very solid, but just that sort of matches with this policy cycle that we have today. So I think this process for me as a participant was very useful actually in that exercise of distilling the most important insights, boiling them down to just 10, and also focusing on what is the new insight. I think this is an interesting model for mobilizing expertise, and actually something that we also discussed in the context of the SDGs. Can we have something more frequent than the 4-year Global Sustainable Development Reports, and also could something similar be done in other issue areas, for example, biodiversity and nature protection. So I will stop here and thank you very much for the floor.
Thank you. So this is the value of bringing these different, but also different but same policy agendas together to kind of learn from each other. So we are remarkably on time, would you believe it, thanks to our speakers. So we now have some time for questions. Any questions from the audience? Oh wow, you're all awake, amazing. So we'll take the first 3, get a response, and then we'll take the next 3.
Okay, can you hear me? Yeah, really it's been a privilege to be here in the audience. Firstly, I have to say this, I mean it's very rare to come across economists and physical science, people from the physical science at the same platform, so it's been really enriching. And I have 3 questions.
If I just ask you to introduce yourself as well.
Okay, so I'm Ananya. I am a climate scientist and I work with UNESCO's Research Institute, Category 1 Institute, UNESCO MGIEP, based out of New Delhi, yes. So the first one, I mean this might sound really stupid, please excuse me if I sound silly, but this is for you, Jim. So I wanted to know, are you happy with the percentage of influence science and assessment has on the negotiations? And are you happy with the COP? This is one. And then for Detlef, I just wanted to know, you did mention a very important point that important things cannot be modeled. And I wanted to know a little more details about what these were. And my third question would be for Asa. Yeah, you mentioned about open access science. Is it still a utopian idea, or you think it's going to be possible at some point in the near future? Yeah, these are the 3 questions. Thank you.
Thank you. We'll take the second and then the third.
Jim Stock, Harvard. I have a couple of, first of all, I agree with very much of what this panel has said. This is terrific. It's very interesting. I think I'd like to, even though I agree with much of what Cameron Hepburn said, I'd like to push back a little bit. I think it's time to move beyond using an older version of DICE, or DICE as a framework for criticism. The current generation of cost-benefit IAMs are regionally granular. They incorporate upgraded modern climate models with fast dynamic response. And importantly, they incorporate damage functions that go well beyond just GDP effect. So for example, I think if you want to take a basis for criticism, I might suggest using the most recent EPA number, which was just finalized the other day, based on a very sophisticated, large literature, modern approach, using something called the GIVE model out of Resources for the Future, that comes up with a $190 estimate of the social cost of carbon. That incorporates, among other things, mortality. Work is being done at the moment to incorporate morbidity effects beyond productivity. Okay, that's comment 1. Comment 2 is, given that that's $190, is this a debate of the past, or are we basically at a threshold now where most of the policies that we're framing or facing are actually going to be cost-effective and cost-beneficial, and really the question is just to get on with it and not really have this internecine debate, which I think is sort of the facts have caught up with, have overcome the terminology.
Mm. We'll go back on the third over here. No, over here in front. It's the third one here. And then we'll go.
Thank you. Bob Ward from the London School of Economics. First, I think we should give a plug to the Royal Society report that was the basis for this panel, which was published a couple of weeks ago, which was based on a meeting that took place in March to look at this issue. And it showed that there are lots of things left out of even the most sophisticated models, particularly suspicious of a model that gives you a single dollar number that expresses the uncertainty. They leave out things like tipping points, they leave out population displacement, war. Frankly, all the things that are going to cause the biggest impacts get left out of the current models. So you're quite right, Jim, that we have declared for a target already, but there are people still using these models to push back on it. Bjorn Lomborg likes to amplify these numbers, and he's influencing people in the development community, including Bill Gates. So it does matter that these models are giving stupid answers. But I wanted to ask Cameron whether, we have, the scientists have the WCRP to coordinate modeling on a much more mission-driven, like Jim said, it could be used to help distinguish between different adaptation pathways. What are the chances of the economists organizing themselves and coordinating so that we get fewer of these rubbish cost-benefit analysis between action and inaction and start doing something quite useful?
Okay, so we'll take that first round, and I know there's 3 here, but we'll just take responses from Jim, Cameron, and Osa in this first round.
Yeah, okay, so I think the question is, am I happy with the way that science is being incorporated? And just to say, I think science has actually been hugely influential over the last 5 years or so. I mean, if we think about the special report on warming of 1.5 degrees, it didn't invent the concept of net zero, but it brought it to the attention of the world. And now we have multiple countries who've set net zero targets. The UK, we have a government department with net zero in the title. I think if you look at the overall picture, the science has been hugely influential. Where I think it could be more influential is on the how we can actually take the action and move things forward. And there perhaps I find policymakers are a bit less able to listen to the messages once you get down to the granularity of it. This was actually aimed at Cameron, but while I've got the microphone, could I come in on DICE and social cost of carbon, where I can detect quite a big difference between the US and Europe in the approach to that. You've got the social cost of carbon built into primary legislation in the US, and it means the marginal damage. That's what you mean by it. The social cost of carbon in Europe now means the marginal cost of abatement in order to get to a given target. And so we are actually diverging, quite a lot there. And I might also say, I went to an event earlier afternoon which was to commemorate Salim al-Haq and his contributions. And there was a very strong intervention from the Bangladeshi government saying we are never going to place a value on a human life, which was an issue that bugged the IPCC second cycle and almost caused it to crash. So we are going to have some big debates about these issues.
Thanks.
Goodness, well, I'm going to, perhaps to everybody's surprise, say that I think both Jim and Bob made exceptionally good points. So Jim, I mean, you appear to perhaps to have disagreed, but Jim, you're absolutely right that you've moved on a long way from DICE. It is a little bit of a straw man. Bob, you're also right. Well, it should be a straw man, but Bob, you're also right that it's still influential. So it's still important that we clarify that we've come a long way from there. There's more to be done, yes. But we are, as I perhaps didn't communicate clearly enough, we are moving in the right direction here, especially recently. There's also a lot more to be done. So those two things can be true at the same time. Jim, I think you point in your second kind of comment, perhaps the most important thing here, which I actually contemplated putting into my slides, but actually I was over time, embarrassingly sorry, as it was, which is that not only are we moving away, as Jim said, from this kind of cost-benefit analysis because the politics has done that for us, thank goodness. I think we're even moving away to some degree from aggregate cost effectiveness sort of analyses to start to get to, I think it was the point made by, well, actually, Jim, you made it. How do we do it? So not just is this policy better than that policy, but actually how do you implement a contracts for difference regime in offshore wind? So we want really, really, really specific advice, actually. And sometimes I feel like our modelling toolkits aren't up to that task yet. You know, government says, what do I do here? And saying, well, your price of carbon is X is not good enough, or even saying you should internalise the positive spillovers from renewable deployment with a pull-through policy isn't good enough. They want advice on the specific auction mechanism that is going to work, you know, that sort of thing. And we can start to give that advice. And to Bob, your point, could we get ourselves together? Could we follow Detlef and actually do a kind of Stanford energy modelling forum equivalent for climate modelling on the economic side of things? Well, you were at the last meeting that talked about this in Venice, and I didn't make it. So you actually have a better idea than I do. But I think we're in a better place now than ever before. Perhaps there's hope there. But I'm interested in your thoughts.
Thank you. We'll come back to Elsa. Do you want to make a comment? Yeah. I'll have also first and then back to you.
Yeah, thank you for the question on open access science. I will say it's not an agenda that I follow closely, so maybe others on the panel or in the audience would be able to comment. But I just want to make one point. I think it feels like we also need to move beyond that. I mean, that's a minimum, a basic block, of course, to make it openly accessible. But I think what we are hearing and talking about now is more not just passively available science, but actually communicating it, making it actively relevant to policymakers, meeting their needs in this time of rapid transition. And also, I think in light of the exponentially increasing number of scientific papers, when we looked at the SDG literature, there's been like a 15-time increase over the last 5 years, and I'm sure it's very similar on climate change. We must be able to come up with better ways to synthesize the science. Thanks.
Thank you.
Yeah, thank you. Maybe just a brief word on the models. And I think the first step is we have to discuss or identify what we mean by a model. Because if you go to the mathematicians, they have a completely different, I mean, an equation for them is a model. What we typically refer to is, in fact, a differential equation that we solve numerically. I mean, you can have a model that is statistical by using statistical relations to, in fact, simulate something or predict something. We typically actually solve differential equations and physical equations, and so you can solve it. There are processes at a very small scale and that we don't yet resolve. And for instance, precipitation is one. The freezing ice, all these little, really small scales we just get the cloud convection, for instance, we still don't really resolve. And so in principle we could, but we don't have yet the horizontal resolution. But there are processes we don't have equations for. The whole biological part, for instance, is very hard to model mathematically. Human interactions, so people actually have said in Kigali, we really need city models with human included to also better plan the cities for the future. So my social scientist colleagues say that you cannot actually predict a human. You cannot do this. You cannot simulate a human. So these are maybe processes we can never do. We should try. We need to try. But there's a lot of research really required how to do this and how far we can go. If there's something fussy, we have to leave fussy. And so, a lot to be done. Very exciting. Thank you.
Thank you for those comprehensive responses. Okay, we'll take the next round, starting with, we've now got 1, 2, 3, 4. 1, 2, 3, 4.
So, thanks very much. My name is Chidi Oti Obihara. In terms of being involved in the research community, I was the 2022 Senior Research Fellow at Project Drawdown, but before that I was a non-executive director of the Green Party, focused on finance policy. And before that, I ran a small desk at Morgan Stanley, so I came from banking into environmental policy. So my question is broadly about some of the bigger philosophical questions about the use of science research. And I tried to listen very, very closely because this is a desk with almost 200 years of experience gathered into a very small number of people. So very intense subjects being discussed. The idea of this utilitarian approach to science is slightly limiting. And I got the impression that we agree that it is slightly limiting because the rights and responsibilities that we bring to these fora are very heavy, especially in the context of COP. And it was illuminated for me by Jim saying very casually at the beginning of his presentation something that really resonated very heavily. He said, we start off looking at these things as snapshots when we really should be looking at the history of how we got to this point. A huge, huge point, an issue. We're at 420 parts per million. We got here from 350 about 100 years ago, but it's accelerated. And when the system is changing, measuring it and measuring its impact while it's changing, I think talked about Professor Zakri's issue about the how and the what. You're trying to take a photograph of a running horse and then be definite about it. It's impossible. So to be very specific, could any of the panel members talk in a bit more detail about the utility of science as a storyteller that talks about how we got here, what the causative factors were for getting us here, rather than being an all-encompassing solution for everything, which is impossible. So I think that helps us frame solutions better. Thank you.
Thank you.
Thank you, Chair. Thank you for sharing your experience and your wisdom. I realize that there is rivers of scholarship flowing here, and I think at the end of the question I will be embarrassed. I'm feeling a little bit shy, but let's have a look. My work is on capacity building with SMEs, with factories, technical capacity building on social and environmental aspects. Much of this is funded by development agencies and large brands. So the first part, you mentioned about the different science, fields of science. I'm curious, do you feel that sometime there would be where moral science would somehow integrate science about physical world, science about economic aspects for students? The second aspect, in the outside, when we talk of policymakers and the inaction or the inertia, we talk of sometimes election cycles. But are we also ready to accept that sometimes the policymakers and the technocrats are having the don't look up situation whereby there's all this valuable science and they're like, what? No, what do you want to sell to me? Because sometimes it's a matter of habit. What do you want to sell to me? Why should I do it and why should I do it now? Yeah. Now the one example where the development agency, the German development agency tried to move this approach because they do a lot of work in the global south. They looked at a sectoral approach, in this case the textile industry, whereby their stakeholders are the taxpayers, but also the Economic Cooperation Ministry. The mandate was to move the needle, to make changes so that German businesses can continue to source and the environmental impact goes down. What did they do? They came up with something similar to what Professor Yu mentioned about the regional approach with science. They came up with three groups run the Regional Universities Network. So it was a competition between the, it ended up being a competition between the universities of the global south on science, who can do better, and why should they do better? Because the industry there wants it. And why did the industry start wanting it? Because they developed a grouping where the industry got together and said, we have to make improvements because we want to continue selling our products, reduce our impact and so on. And finally, they came up with a network of environmental authorities, REEF, Regional Environmental Exchange Forum, where they had some participants, universities from Europe, some from other parts of the world in the global south. And while they called it sharing, you could sense the competition. Yeah, when one university or policymaker wanted to do something better, the other was, oh yeah, we got to do that too. Can I copy paste and so on? Thank you.
Thank you.
Thank you for the very insightful discussion. I'm Shweta from Royal Society of Chemistry, South Asia. I work at the interface of science and government. I influence various governments across the national and state levels. So my question is this. There's been a lot of debate at other side events about the loss and damage fund and how exactly to make allocations and how do you budget things, how do you distribute these. Why isn't science, or is science doing enough to inform their decision and swing the outcomes in the right manner, in an equitable manner? And just to expand that question, most of the evidence we have today is from the global north. Very little comes from the south. And I was trained and educated in the UK. I moved back to India. I understand both systems and they're very different. I think this is true of the north-south divide. Navigating those systems, starting from collection of data all the way to sort of influencing policy works very differently. And are we adapting to that? What is the North doing? Because for reasons well known to all of us, the global North is the intellectual capital. The South has potential, but we've not been able to tap on it or develop it. So particularly, Jim, what can we do about this? And is there some measures being taken already?
Thank you. And the final question.
Tennant Reid from the Australian Industry Group. Thinking particularly of the audience for economic assessments, but this may be a broader issue, there is a tendency to just desire from policymakers, from stakeholders, desire the number and to file off all of the qualifications and asterisks that come with the number. In addition to working around that desire, what would you say to us about the practices that we should have in receiving what you tell us?
Okay, great. Thank you for those important questions. So I'm going to hand over to the panelists now to respond to those questions, but also to frame these as your final remarks. So you have about 70 seconds each. Just to respond to the questions that are relevant to you and to close us out from your perspective. And we'll go in the order of the presentation. So we start with you.
Right, okay, that gives me plenty time to think about a particularly challenging set of questions there. Let me kind of try and join things up, because there were hints about storytelling, how did we get there, the role of moral sciences, etc. And let me just say on how we got there. I mean, the last Working Group 3 report for IPCC, we produced very specific numbers on historical emissions from different parts of the world, which gives an explanation of who contributed. And maybe that then would jump into the other question about loss and damage funds and what that tells you about contributions. But you can't do that without appeal to the moral sciences and the philosophy that was then asked in another question. And so, I know that there are groups of scientists going out and asking, for example, what was the effect of colonialism on contributions to global warming? Probably an unanswerable question, but it absolutely needs law, philosophy to actually get you to these issues. And in the 5th cycle of IPCC, we had several chapters on ethics, law and morals. We didn't repeat it in the 6th cycle because many of the references were to Rawls 1971. The literature didn't sort of move on quickly enough to justify it. But there are a big set of challenges there that we need to address. Thanks. And I think we will. Future IPCC reports, the Loss and Damage Fund, will come in there. I think we will be able to see capital L and capital D for the first time in an IPCC report, because we now have a fund that's actually been agreed. And my one appeal to practices, let me go into the financial community. We get lots of requests for information on investment needs and give us some numbers on carbon budgets. Please ask us what the numbers mean, as well as just asking for numbers. That would be really good.
Great, thank you, Jim. Thank you for those final remarks. And I think lots of fodder for the 7th assessment and beyond to think about how to update. Detlef?
Well, I will pick two things because I can think about it and wrap my head around it. The first one is what you said, how did we get there? I mean, you basically can take Jim's answer, but coming from a physical point of view, it is actually exactly what we need to ask. I mean, basically, you can come think about the CO2 increase, but we had points in history where we, in fact, had similar CO2, but completely different responses, and so we call this actually paleoclimatology, or where you really need to think about how is this system moving into something. It's not just a number, it's not just the state itself, in fact, it's how you get there and how you get out. And that's where it's actually absolutely true. How did we get there and how do we move forward from where we are? But that depends on how you came here. So that's absolutely true. It's true for many aspects, and really understanding the dynamics, we cannot do otherwise. The other one is about kind of I think the question really was collaboration. We see this also in the health sector. I mean, it's not just give me your number and I want to do something. We really have to sit together and first of all understand each other, and that's a language problem, but it's also a real collaboration, co-design, collaboration. And I think that this is what we really need to do also in a much broader sense.
Great, thank you very much. Cameron.
Well, I'm going to close by just picking one of those issues and ignoring a lot of important things. But I'd like you to kind of pull out your phone and have a look at a map and ask yourself what's wrong with the map. And if you have a look, if you haven't done this analogy before, it's quite surprising, I find. So have a think of it. What's wrong with the map that you've got in front of you? And so I'm looking at this one and I'm thinking, well, it's quite useful, but the roads aren't green and the land isn't white, and there isn't a massive blue circle sitting on top of where I am, right? The map's wrong, and it's wrong in some quite serious ways, but it's really useful. And I think, Tennant, to your question, what do I want to see on the other side of the fence? It's an awareness that all models are just maps. They chuck away vast amounts of reality. You know, there's no trees, there's probably not the solar panels on the top of the building, but they're useful because of what they've thrown away, but they can also be really misleading if they've thrown away the things that you're interested in.
Right.
So if it doesn't tell you where side event 6, building 85 is, then the map's really annoying. But, you know, so ask yourself, is the model suitable for the purpose that I'm using it for? Is it a garbage in, garbage out story? And I guess perhaps to build on the previous comment, what does it therefore all mean?
Great, thank you. Professor Zakri.
I'd like to conclude by quoting Gus Path. As you know, he's the former advisor on climate change to the US government. And that also applies to some of the advanced sciences that you guys are talking about this afternoon. And he said, I used to think that the top environmental problems were biodiversity loss, ecosystem collapse, and climate change. I thought that 30 years of good science could address these problems. I was wrong. The top environmental problems are selfishness, greed, and apathy. And to deal with those, we need a cultural transformation and a spiritual one. And we scientists don't know how to do it. So reflect on that. Maybe we can provide better options for the negotiators or policymakers today. Thank you.
Thank you. And finally, also.
Yes, hard to follow. But I think I would just maybe riff on your question, how did we get here? Because I think an equally important question is, how did we get out of there historically when we were in bad places? And that's something we actually missed a little bit when preparing this Global Sustainable Development Report, looking at transformations in a broad sense, of course broader than climate related, drawing on history, arts and humanities. And I mean, of course we cannot compare exactly with previous change processes and so on, but potentially some dynamics we can learn from. So I would say that bringing history into the mix and building that collective memory, that we have a very fast-paced world, so remembering what we have been through in the past. Thank you.
Well, thank you all so much. I had 5 things I've taken away from the panel's discussions, but also the questions and this discussion. One is the importance of context. And by context, that's local context, contemporarily, but also historical context. The second is that in order to stay relevant and fit for purpose, the science enterprise, science in the broadest definition, and the ecosystem needs to evolve. I always thought that my training in global health was severely lacking in history, in philosophy, and that sort of thing. So how do we ensure that we are really training a new cadre to think in different ways? The third is thinking about how can science be conceptualized as science as storytelling for collective memory. I really like how you framed that. The fourth is the importance of humility. And recognizing the boundaries of what we can and can't do, and how we need to really lean into these complexities, these intangibles of how we organize society in order for science to be part of contributing to effective action. And the final is about justice. So we talk about just transition, but if science is going to be well placed to support action, we also need to ensure that we have an emphasis on just science. So from stakeholder participation to who is generating knowledge, really addressing that knowledge co-production and making that more equitable. So those are the kind of 5 key take-homes personally, but there's obviously a lot more. But I'd like to thank the panelists for the really thrilling discussion, and your participants, for really bringing your A game and elevating the conversation. So thank you all very much for joining, and thanks to those online as well. Pleasure. Make it easy.